Okay, let's have a look here. Okay. Um, show that in general, right minus left equals that. Okay. Hang on, let me just check something on my phone here. Sorry. Okay. So, well, we know that the right sum is the sum um, from n equals 1 to n delta x, which is b minus a over n, times f of um, a plus. But actually, you know what? It'd probably be better to write the terms out. So, um, it would be, if you want to split the line up like this. So that's a, that's b, and we can call that x0, and then that's x1, etc., etc., etc. So the right sum would be b minus a over n times, and we start at x1, and then x2, all the way up to xn. And then the left sum is b minus a over n, but we start at x0, and then we go all the way up until xn minus 1. So if you subtract this, b minus a over n, and x1 minus x1, so they cancel diagonally like this. So you're left with fxn minus fx0, which of course is fb minus fa all over n. So that works. And then 56. Explain why, if f is increasing on AB, the error between the left and the right for the area A below the graph is at most that. So, okay. Whoops. So let's say it starts here at A, which I'll call x0, and we'll go to B, which we'll call xn, and it's increasing. Okay. So the explain why f is increased. The area between the left or right and the area A below the graph is at most that. Okay. So let's look at the left area. So the left area would be this. So that would be b minus a over n times f of x0 plus f of x1, etc. And the area so the area because if it's increasing, it means it will have to be bigger than, I don't know, well, increasing, maybe not constant, but if it was constant, I guess it could be equal. And then that would be less than the left plus all these little pieces. We'll call this like epsilon 1, epsilon 2, etc. But we could probably put an upper limit on these by making them little rectangles. So that would be the difference in the height. So that would be f n plus 1 minus f n. And n starts, let's just be clear, at 1. So that'd be 2. No, I have to be careful here. That's x1. x1 minus x0. So that would be starting at 0. Okay. The difference in the height times the delta x. So that would be at most the error. So the delta x is b minus a over n. And that's the sum of the difference. Starting at f1, fx1, all the way up to fxn, and then minus fx0, all the way up to xn minus 1. Sorry, that's kind of a bit messy. So they all cancel except for these two here. So that would be b minus a over n, which is an fb minus fa, which is exactly what we have here. And the argument for the right is the same, but it's just going to be, the inequality is just basically going to be the other way around. So it's not in any way significantly different. So that answers those two questions satisfactorily, I believe, because we got exactly the result that we were supposed to.